Now on its surface, metallic behavior is going to be the easiest of our trends. What a surprise! As you come across toward the metal side, things act more metallic, and as you come down the periodic table, things turn more metallic. The very dividing line of our metalloids helps us remember that really easily. But we're going to find out there's a lot more to it than that. Metallic behavior is going to really be all about how well electrons are being shared to create what are called metallic bonds. Now these aren't bonds the way that you're used to thinking of things, where it's actually attaching things together. This is more like a communism sort of system where the electrons are being freely shared throughout all of the different atoms. At least the outermost electrons are being shared. And that results in a lot of strange properties when you get down to the way that you think about things. Now, just to point out some of those properties, and a lot of these are going to be very intuitive, we know that metals typically are going to have shine to them. They're going to have luster. They can have different colors, but most are going to be silvery. Even gold has a little bit of that kind of silver sort of tone to it, or copper. But they're going to be fairly reflective. They're going to be malleable, and they're going to be ductile. Remember, malleable means you can hammer them, coming from the same root as the word mallet came from. And ductile means you can stretch them. So hammerable to be shaped and hammered into a thin sheet, and ductile can be stretched into wires. They're going to be good conductors of heat and electricity, and that's going to be because they can freely move energy through them very easily as electrons are being exchanged between different metal atom centers. Now our metal oxides, we haven't talked about these yet, but these are going to be things where you have the metal atom, which we'll just generically say is M, combined with some number of oxygen atoms. The X is going to be the subscript, how many atoms are there, not writing it improperly. Remember that oxygen is just O. In other words, I'm writing it as something like Fe2O3. We can actually have a variable number of metals as well. So iron 2O3, that's going to be rust. It's going to be an ionic solid. We'll talk about that when we talk about our bonding characteristics. And it's worth pointing out that these are typically going to be basic. They're not going to act as acids. Now they're going to tend to form cations in our aqueous solutions, and we've seen that when we looked at all the common ions over into this section of the periodic table. They were typically going to be metal atom to some plus charge. So typically we're going to be forming our cations when they're in water. In other conditions, we can have other things happen. Now, contrast that to all of our nonmetals. Our nonmetals typically are not going to have luster, and they can have lots of different colors. Sulfur is a bright yellow. Many of them are going to be clear. Our halogens can have lots of different colors to them as well. You'll have lots of colors there. They're typically brittle. Some can be hard, some can be soft. Example of that, sulfur again. They're going to be soft. You can grind those crystals very easily. Some can have a mix of the two. Carbon that's fairly pure can be either charcoal or it can be a diamond. Brittle, but some are hard and some are soft. They're going to be poor conductors of heat and electricity. You're not going to have electric easily come up a broomstick that's made of wood. That's one of the reasons that a lot of the high voltage equipment for the handling of things are going to be made either of wood or of various non-metal compositions like fiberglass. Even then, don't go out and try that at home. You need some serious training for high voltage. Our non-metal oxides are going to be molecular substances. In other words, we're going to have these with actual covalent bonds. Those are the things that we consider to be real bonds in our minds. If you're thinking of ball and stick models, those are the sticks. Metals, they don't have any sticks on their models, and neither do ions. Now, our non-metal oxides are going to be molecular substances, and these are going to be forming acidic solutions. We'll see that when we get to the acids later in the course. Now, typically, they're going to form anions. These are going to be negative charged ions, or oxyanions. What we mean by oxyanions, we're going to have some atom in the center. We're going to have some number of oxygens, and that can be a variable number depending on which of the ions we're talking about. And then it's going to have some sort of a negative charge on it. We'll be talking about the sulfate ion extensively throughout the course. So SO4 double minus, you don't need to memorize that yet. That'll be something we learn about when we talk about our ions. But this is going to be an anion, or at least this one specifically is going to be an oxyanion when it's in water. And when it's in water, if it has H pluses on here, That's going to be sulfuric acid. So we're going to have lots of those sort of things present. That's why we were saying that they can typically form acidic solutions when they're in water. That's metallic behavior in a nutshell.